little visage up on the, wants to be more anonymous, can go to a black screen. It's very timely, this presentation, because I'm sure you're all aware of the UN report that just came out this week and said how much we are all on thin ice. And this, I think maybe some of the presenters are going to kind of reference the report. We're obviously not really doing anything much about it, but we will have the link to it in the PDF that we're going to send out afterward with some of the resources and some of the actions that can be taken. So you will be able to see that. The order of the presentations, Betsy and Angie are going to kind of tag team it, and they will be going first. And then Barb is going to close us off. If you have questions, we have kind of a protocol around questions in that there'll be each of the presentations, the individual presentations, we're going to save a little time at the end for questions that are specific to that presentation only. And they would be like clarifying questions that have to do with clarifying information from one of the slides or something like that, not general questions that have to do with any kind of policy implications or things like that. Those will be all after everything is done. If you have a question, you can either put it in the chat and I'll be monitoring that, or you can wait until the end of that presentation and just kind of raise your hand. If you put the question in the chat and it's one that's more general, I will probably ignore it. Don't think I'm ignoring you, but I will have made a judgment that it's more of a general one and we will do it. If you actually ask a question, you've raised your hand and you ask a question that's more general, then either the presenter that you're questioning or I will be saying, let's hang on to that one and we'll ask it at the end, because I think that's a more general question. So without any further ado, I'm going to turn everything over to Betsy and she will start us off. And I am very excited about this.
Thank you, Kathy. Let me share my screen. Just a moment. All right, do you see that?
Yep.
Good. So yes, today Angie, Barb, and I are going to be talking about the crisis in climate and water. If that sounds grim, and there is obviously plenty of bad news to be had as we contemplate the world we might leave to future generations. There is hope too. There's much that we can do in our own lives, and that's going to be our focus today. First, though, the bad news. I'm going to run through these slides quickly because I expect you all are fully cognizant of the climate crisis. So when you see a graph, for instance, just look for the trend line. We're not going to linger on these slides. This part of the presentation, I hope it's going to go quickly. So to begin, global temperatures are rising. This is the classic hockey stick graph. Since 1900, when the accumulated effects of the Industrial Revolution began impacting the climate, global temperatures have risen more than 9 degrees Fahrenheit. The past 8 years were the warmest on record globally. This is Europe in the summer of 22. The oceans are warming. The annual global sea surface temperature has risen steadily since 1950, as you can see over here, with the implications for things like the corals, which are bleaching. The oceans are acidifying. When high levels of carbon dioxide in the atmosphere combine with water, they make acetic acid. The ocean's pH, which you see down here, has dropped steadily over the past 50 years. Ice cores show us that the atmospheric concentration of CO2 has risen. It was stable over the last millennium until the early 19th century, when it started to rise. and its concentration is now nearly 50% higher than it was before the Industrial Revolution. Measurements begun in 1958 at Mauna Loa Observatory in Hawaii show that CO2 concentrations have risen from less than 320 parts per million in 1958 to more than 420 ppm today. Between 1966 and 2013, 48 species of birds have moved northward by more than 200 miles. Of the 305 species studied in this particular study, 186 or 61% have shifted their wintering grounds northward since the 60s. And the Audubon Society tells us that 2/3 of North American birds are at increasing risk of extinction from global temperature rise. And the glaciers are melting. They're disappearing faster than earlier thought. 2/3 of them are projected to disappear by 2100 if current trends continue. Of the 150 glaciers that existed in Glacier National Park in the late 19th century, only 26 remain. These pictures are from 1910 and 2020 at Glacier. 1.9 billion people worldwide depend on healthy glaciers for water supply, especially in Asia, but also in Europe and the Americas. So this is the hard data. This isn't opinion or speculation or theory. This is just what the facts are. Now, the consequences, and as you know, we've all heard that it's not possible to tie specific weather events or conditions to global warming, but there is increasing unanimity among climate scientists that global warming is bringing really terrible consequences. To start with, mega droughts. Mega droughts cause water access crises. Billions of people around the world lack adequate access to clean water, and the problem is expected to get worse. Much of Central and Southern South America is suffering from extreme drought. California and all the American Southwest are suffering from 23 years of drought. Great Salt Lake, you see here in 1985 and 2002, it's a third of its 1985 size, and it could be gone entirely in 5 years if steps aren't taken. This is not simply due to climate change, but also to really explosive overdevelopment. And drought triggers hunger and famine, which drives mass migration. At the same time, as you're aware, we have catastrophic floods. A third of Pakistan was submerged in 2022. We're going to hear a little more about that from Barb. Auckland, New Zealand, at the lower right, recorded its heaviest ever its heaviest ever flooding, January 31st. More torrential rain followed. Atmospheric rivers over California have brought flooding and destruction, and no substantive relief from the mega drought. Another consequence is a threat to our national security. The Pentagon believes that climate change is the most serious threat to our security. They call it a threat multiplier with consequences including damage to installations from drought, flooding, wildfires, and hurricanes. This is Tyndall Air Force Base after a hurricane in 2018. Expanding global chaos, failed states, wars over water, and the warming of the Arctic, and thus another sea to defend. This shows the fall off in the disappearing Arctic sea ice. Sea levels are rising. Around Virginia Key, Florida, the sea level has risen 8 inches since 1950, and its speed of rise is expected to accelerate. It's now rising by 1 inch every 3 years. The Carolinas and Mid-Atlantic, too, are experiencing severe effects of rising seas, and citizens of island nations who have done little to contribute to this existential threat are making plans to abandon those islands. The Gulf Stream is slowing and could collapse with catastrophic implications for weather in Europe and North America. Of course, we're familiar with increasingly severe wildfires and longer wildfire seasons, increasing numbers and severity of tornadoes, hurricanes, and derechos. This was Selma a few months ago. Climate change threatens food security with crop failures, livestock population collapse, and logistical failures due to drought, flooding, superstorms, and wind. This is a grain elevator in Iowa that was destroyed by the derecho a couple of years ago. Also, pandemics, rising temperatures and deforestation force wild animals and disease-bearing insects to move closer to human populations, and they share thousands of viruses with other mammals. They dramatically raise the risks of zoonotic disease. Overall, the World Health Organization estimates an increase of 250,000 excess deaths per year between 2030 and 2050 from climate change caused by heat-related morbidity and mortality, increases in vector-borne diseases, increased respiratory illness, and death and injury from extreme weather events. So now the hope. For me, the proximate source of hope is this book, Drawdown, the most comprehensive plan ever proposed to reverse global warming. That sounds like an audacious claim, but bear with us. The editor is Paul Hawken. Hawken is a giant at the intersection of ecology and economy. Much of his work explores market-based solutions to environmental problems. Hawken created Project Drawdown in 2013 as a collaborative effort among 200 researchers and advisors who came together to model the most substantive solutions to reverse global warming. Drawdown lists, in order of effectiveness, the 80 best things we can do individually and collectively to reverse climate change. Drawdown solutions are stated in the number of gigatons of carbon dioxide, which will be saved if we implement these measures. In 2021, the world's people emitted 36 gigatons of carbon dioxide, as well as other heat-trapping gases. That's 36 billion metric tons. If you'd like a visual image, think of it this way: 400,000 Olympic-sized swimming pools hold about 1 billion metric tons of water, or a gigaton. We emit 36 times that in a year. When the Drawdown scientists then calculated the greenhouse gas reductions each strategy would accomplish and the cost of each compared to the cost of continuing with the status quo, then they could rank these strategies, determining which will be the most effective in arresting and reversing climate change. We're going to talk about just a few of those, and I'm going to pass this to Angie and stop my share. And Angie, you're on.
Can everybody see that?
Yes.
Great. Well, as Betsy pointed out, it's a well-established scientific fact that the major cause of climate change is that humans are putting too much carbon dioxide or CO2 in the atmosphere. From the Mauna Loa Observatory, this graph shows there's a 33% increase in CO2 concentration since 1960. So how do we figure out how to solve this problem and reduce the CO2 in the atmosphere? Well, first, you have to understand the carbon cycle. The carbon cycle is a circulation of carbon on Earth in which atmospheric carbon dioxide is converted by plants through photosynthesis to oxygen and organic matter, and is then converted back to CO2 by respiration, decay, or combustion. Before human-caused CO2 emissions began, the natural processes that make up the global carbon cycle maintained a near balance between the uptake of CO2 by vegetation and the ocean and its release back to the atmosphere. However, the burning of fossil fuels by humans has upset this equilibrium. To restore balance in the carbon cycle, clearly we must reduce our emissions from fossil fuels, but we must also figure out a method to remove CO2 from the atmosphere. The term carbon sequestration is used to describe both natural and deliberate processes by which CO2 is either removed from the atmosphere or diverted from emission sources and then stored in the ocean, terrestrial environments, and geologic formations. Today, we're going to focus on terrestrial carbon sequestration, which is accomplished by trees and plants through the process of photosynthesis. Photosynthesis is the most essential natural process of life on the planet, since it regulates the steady dioxide into the soil and creates oxygen, which we need for survival. The movement of carbon from the atmosphere to soil via green plants represents the most powerful tool we have at our disposal for the restoration of soil function and the reduction of atmospheric CO2. Photosynthesis takes CO2 from the air and converts it to sugars and oxygen using this chemical formula at the top. Those carbon sugars are then consumed by the soil microbes. Soil microbes provide plants with nutrients and enrich the soil with excretions, so there is a symbiotic relationship between plants and soil microbes. Through photosynthesis and plant decay, plant biomass and soil organic carbon are formed, or SOC. Humus is formed, which gives carbon-rich soils their characteristic dark color and is resistant to decomposition. A healthy soil, which is loaded with soil microbes, soil organic matter, and humus, absorbs water and doesn't dry out. It also has the capability of sequestering carbon through photosynthesis and plant decay, so the carbon stays in the soil. The problem is that most of the soil on our planet has been depleted by deforestation, mining, improper grazing, and poor agricultural techniques. For example, the use of herbicides and pesticides disrupts the symbiotic relationship between plants and soil microbes, so the microbes aren't able to enrich the soil. The UN has determined that 40% of the soil on our planet has been degraded. National Geographic puts that number at 75%. The good news is that there are solutions to this problem. The one we're going to talk about today is called regenerative agriculture, or RA. Regenerative agricultural practices restore degraded land. Huh?
Angie, if you turn off your video, it might help. It's cutting out of your words a little bit. It said you had a bad
okay.
connection.
Sure. Okay. Let's see. Regenerative agricultural practices restore degraded land. Is that better?
Good.
They include no tillage, diverse cover crops, no pesticides or synthetic fertilizers, and multiple crop rotations, all of which can be augmented by managed grazing. The purpose of RA is to continually improve and regenerate the health of the soil by restoring its carbon content, which in turn improves plant health, nutrition, and productivity. For this reason, it's commonly called carbon farming. RA presents us with a triple win. It improves the soil, provides us with healthy food, and sequesters carbon from the atmosphere. Let's take a look at how RA accomplishes this. Tilling is the process of churning the top layer of soil, typically with a plow, to prepare the field for the planting of a new crop. It is used to aerate the soil and control weeds. But during this process, water in the freshly turned soil evaporates. Soil itself can be blown or washed away and carbon held within it released into the atmosphere. Tilling can make a field nutrient poor and less life-giving because it destroys the healthy soil structure created by the microbes. In a no-till system, seeds are planted directly into undisturbed soil. The benefits of the no-till approach are multiplied when used in conjunction with other sustainable practices, such as cover crops. Cover crops sown into harvested plant residues crowd out weeds and provide fertility and tilth to the soil. Experimentation has taught regenerative farmers to plant many different varieties, such as legumes, vetch, cowpeas, alfalfa, etc. Each plant adds something to the soil, from shading out weeds to fixing nitrogen and making phosphorus, zinc, or calcium bioavailable. The use of cover crops make it possible for farmers to not use chemical fertilizers. Crop diversity through rotations helps build better soil structure. Incorporating different crops that grow in a different time frame and have varying root structures gives soil microbes different food sources, which ultimately makes soil healthier. Regenerative grazing practices build soil health by managing livestock on perennial and annual forages, rotating pastures, allowing grazing areas to renew, building native grass populations, integrating livestock and crops, and supplementing with feed are all excellent sustainable grazing practices. Well, farming is a risky business due to the unpredictability of nature and the market, and changing farming techniques is extremely risky for farmers. Farmers are a fearful bunch, probably because their families rely on their income. We can support farmers interested in making this transition to regenerative agriculture. If we choose to buy foods that are produced in this manner, consumer demand will encourage farmers to practice RA. The tricky part is knowing which foods are grown sustainably. As you now know, regenerative agriculture means more than certified organic, but that's a great place to start. Whoops. One potential solution to this problem is to buy foods locally so that you know the farmers and what type of farm they operate. Or if this isn't possible, encourage stores to reveal the source of their produce. Another solution is to do some research and learn about companies like Timeless Seeds. I have a special place in my heart for the Montana farmers who in 1989 had the courage and audacity to abandon their family's commercial farming practices and make the transition to organic farming. Initially, they were just interested in building soil health. But soon they recognized the potential of growing lentils and other legumes as nitrogen-fixing crop that they could grow in rotation with grains and then be sold to consumers. They eventually formed Timeless Seeds, which has grown into $1 million company that markets organic lentils and grains all over the country. Now, thanks to Timeless, Montana grows nearly half the supply of the country's lentils. Their story is told in The Lentil Underground, a book written by Liz Carlisle. If a small group of Montana farmers can improve soil health and make their dreams come true by growing organic lentils, it gives me hope that each of us can have an impact on reversing the trajectory of climate change.
Mhm.
Betsy?
Thanks, Angie. So what else can we do individually in addition to supporting farmers who use organic and regenerative practices to combat climate change? Here are a couple of the top strategies from Drawdown. One is adopting plant-rich diets. This will come as no surprise. Raising livestock accounts for at least 15% of greenhouse gas emissions globally. Cattle are the worst offenders, emitting vast amounts of methane as they digest their food. Associated energy consumption to grow feed produces carbon dioxide, and manure and fertilizer give off nitrous oxide. It's possible to eat well further down the food chain and to reap health benefits in the bargain. A groundbreaking Oxford University study in 2016 argued that a worldwide switch to plant-based foods would reduce premature mortality globally by 6 to 10%. That potential health impact would yield $1 trillion in healthcare cost savings and many trillions more when the value of lives lost is taken into account. Such a worldwide transition could reduce global emissions by as much as 70%. But that's perhaps too much to hope for. Drawdown goes for a more attainable goal, proposing that 50% of the world's population restricts their diet to 2,500 calories a day, which seems generous to me, and reduces meat consumption overall for a savings of at least 26.7 gigatons of emissions just from dietary change. The accompanying reduction in deforestation could reduce emissions by an additional 39.3 gigatons. Accomplishing this goal should involve ending price-distorting government subsidies, such as those for the U.S. livestock industry. The third most effective strategy for arresting and reversing climate change in Drawdown is eliminating food waste. If food waste were a nation, it would be the world's third highest emitter of greenhouse gases after only the US and China. This is particularly scandalous in view of the 80 million people around the globe who go hungry every day. Fully 1/3 of the food raised or prepared does not make it from farm or factory to fork. And all this wasted food contributes 4.4 gigatons of greenhouse gases to the atmosphere annually. In low-income countries, waste typically occurs earlier in the supply chain, the result of bad roads, poor refrigeration, high heat, and humidity. In wealthier nations, the culprits are retailers and consumers, that's us, rejecting imperfect produce, restaurants and dining halls dumping uneaten food, and all of us buying more than we need and losing track of leftovers and other food in our refrigerators. Producing uneaten food wastes resources at every stage, from seeds and water to energy, land, fertilizer, labor, and capital, and generates greenhouse gases at every stage. We can reduce food waste. We need to standardize date labeling on food. Current sell-by dates are unregulated and mostly meaningless. Consumer education, encouraging all of us to understand that a tomato doesn't have to look perfect to taste fabulous, is important. National policy can help. France and Italy have both passed laws prohibiting supermarkets from trashing unsold food and requiring that they pass it on either to charities or to animal feed or composting companies. And all of us can compost our fruit and vegetable peelings, our coffee grounds, and eggshells. If 50% of food waste is reduced by 2050, emissions could drop by 26.2 gigatons. And because reducing waste also avoids deforestation for more farmland, we could avoid another 44.4 gigatons over that period for a total of 70.3 gigatons of reduced emissions. So reducing food waste and going to a more plant-based diet, just two strategies that we can do on our own. And with that, I'm going to turn it over to Kathy.
Okay. We have a few minutes if there are no questions of a clarifying nature that are in the chat. Does anybody have any questions that they have for either Angie or Betsy with regard to their, okay, Keir, and you'll need, yeah, Keir.
Just, Angie went quickly over the book, Lentil Underground. Is that what it was, by Liz Carlisle, did you say?
Yes, I think that this isn't Angie, but I think that's correct. Keir, Barb has put together a great resource
Okay,
list
all right.
for us, and there are going to be a number of things on that'll be available at the end.
Okay, thank you.
Sorry, I was muted and I had to find the unmute button.
Okay, any other questions before we move on to Barb's presentation? Okay, if you'll mute yourself for Barb's presentation. Barb, it's on to you.
Barb, you're muted.
You'd think I'd never done this before, right? Okay, we'll start over again. Water is life. Maniwachoni is a Lakota Indian phrase that means water is life. And without water, we would not have life here on Earth. And it's because of its critical nature that the impact of climate change on our water resources could be and is becoming so devastating. So I'm going to spend a little bit of time talking about water in general so that you understand kind of what makes it so special. In terms of where it comes from, scientists aren't 100% sure, but it appears as though most of it probably came from water that existed in a large gas reservoir that formed after the star that was around here before our sun blew up. And it left not only water, but a lot of other stuff, out of which the planets that we now know and the sun that we now know emerged. And in the process of forming the Earth, the water also became incorporated as part of what we now call Earth. Much of it probably underground. Some of it would have then come out with volcanoes and so forth. We would have gotten additional water with strikes from comets and asteroids in the early lifetime of the Earth. But what we have now here on Earth is that's all we've got and all we ever will have. So where is the water located? This is our total global water. And if you look at it, you can see that a good 97.5% of it is salty water, most of that in the ocean. So only 2.5% of our global water is in fact fresh. And if we look at just that 2.5%, what we find is that most of that water is sequestered in glaciers and ice caps, almost 69%, and an additional 30% in groundwater, which is sometimes quite accessible, but sometimes not. Only 1.2% of the water is found on the surface. if you look at that surface water, which is the most available water for human use, 69% of it is ground ice and permafrost. So yet again, not real accessible. What is accessible is about 28% of the fresh water, and that's primarily in lakes. There's soil moisture, which, as Angie pointed out, is very important, and then some water in swamps and in rivers. And we, living things, carry around a lot of water as well. So the amount of water that we really have to use effectively is vanishingly small when you compare it to the total, less than 1/3%. This is where we find our major rivers, which people usually think of as major water sources, and they're pretty well scattered around the earth, as you can see. Number 1 is the Nile, number 2 is the Amazon, number 3 is the Yangtze, and number 4 is our Mississippi River. Those of you who live in the West are very much concerned with the Colorado river system, and that is listed at number 46. This is one view that I love of what the rivers in America look like across the United States, because each of our major rivers is part of a system and collects water from tributaries that end up coming into a major channel. And that one right in the middle in pink is the Mississippi River, which carries an enormous amount of grain and other goods throughout the the middle part there of the United States. And to look at some of the rivers that are near you, the major rivers that are near you, here's another little graph to show you that. And in terms of the Mississippi, it goes right up the middle here, and you can see the major inputs. Here's the Missouri, which is a major input, the Illinois, the Arkansas, the Red River. So it's bringing in water from a considerable number of more locally major rivers. So what makes water a miracle molecule? The water molecules stick together, something that we call cohesion. And that means that it often appears in sheets, like this drop of water going down into a puddle. It throws water up in sheets, and those sheets will flow. And if they flow in a way that gravity begins to make it fall heavily, we can actually use that. And we can use it to generate power, or to turn the grinder in a mill to make grain and so forth. So water, because of its cohesion, is something we can actively use. Its density is extremely high, and this lets objects float. And that is the foundation for our thousands of years of global transportation. It's got a tremendous ability to dissolve all sorts of solids and gases. And because you can dissolve this material in water, that means that we now have the means to sustain multicellular life. Because if you think about it, your bloodstream is full of water. And in order to nourish all your cells, you need to get nutrients there, waste taken away, and oxygen and carbon dioxide dealt with. And so without solubility, this incredible property that water has, another reason life would not exist. And then we have weather and clouds. Cohesion explains how clouds form, or droplets form in clouds. And if you look at this cloud droplet diagram here, that little circle, what happens is a lot of cloud droplets will begin to coalesce. And when they get big enough and heavy enough, gravity will take over, and that's where we get rain. And this tip top of a rain droplet down below, the cloud droplet, will give you some idea of the dramatic size difference between a drop of rain and the cloud droplets that are in the clouds we see in the sky. The other thing that makes water a miracle molecule is that it exists as a solid, a liquid, and a gas at temperatures that are compatible with life. So as a solid, we know it is ice. It floats. And this for life on Earth in the aquatic realm is hugely important, because if the water in lakes and in the oceans froze all the way down to the bottom, things could not live in water. And the fact that ice floats on the top, it kind of maintains the water below it at a temperature that is somewhere between a little above 0 and 4 degrees or so. And that is going to allow the fisheries and the organisms that the fish feed on to survive. And Angie already mentioned ice and the melting of glaciers and the calving of those down in Antarctica. And that's a sign when you've got liquid somehow getting in there and weakening the structure of the solid, and it will fall off. Now the liquid, as I mentioned, it's very dense, so it allows ship travel, but it also then flows. And that's one thing that allows our transportation to be more efficient and effective when it's going with the current. And it also dissolves, as we talked about the solubility. So the water will hold nutrients and move them around in the ecosystems, both freshwater and ocean water, but it also will carry pollutants. And that is beginning to become a huge problem. And then finally, it's a gas. And as a gas, water vapor exists up in the air. And it exists, I forgot to look this up, but it exists for a large column up above the solid Earth. And the air currents up there, tens of thousands of feet up in the air, are going to distribute this water vapor around the globe. And in the process of doing that, they're going to generate weather, which will influence precipitation and impact agriculture. You probably are familiar with the water cycle. It's really pretty simple. Water evaporates from surfaces where there is water, and it rises up into the atmosphere. It condenses, cools down, droplets form. We get rain or snow, depending on the temperature. And then we get runoff on the land as the land slopes. This recharges groundwater and feeds ultimately back into the bodies of water where evaporation takes place again. If we warm up too much, we end up creating an atmosphere that's a lot warmer. And the problem with a warmer atmosphere is that it can hold more water vapor. So the tendency for evaporation to take place is hugely increased. We end up in many places around the world with less precipitation happening. Therefore, we will get less runoff. The groundwater is not being recharged. We need to use more for irrigation, so we may be pumping groundwater. It's basically a no-win situation, and climate change and global warming are enhancing that warm atmosphere cycle. We have weather patterns, which we've gotten to, I don't know about you, but I watch the weather quite a lot. And one of the main weather phenomena that we deal with is the switch between El Nino and La Nina. And this happens, it depends, over a period of about 7 years, we will have at least one of those cycles. And what La Nina does, which is what we've been experiencing, is produce a cool, wet Asia and a warm, dry Americas. And so you can see where the cool, wet has been. It's that greenish color in the global map there. And then the drier areas are in the yellow. And we've just ended the weather. NOAA declared that we are now leaving La Nina, but we've been there for 3 winters in a row, which is one reason why we've had such dramatic weather across the world. If you're, depending where you are in the US, this map should make a little bit of sense to you to relate your climate over the last couple of years. Wetter up there in the more northerly part of the United States and dry in the southern part. Last year, $29 billion weather disasters worldwide. And the ones that occurred in the US, there were 13 of them, are the ones in the rectangles there. We had one drought that was basically not necessarily every place in the United States, but many places in the United States, and that's number 8. We had 2 floods. Number 1 at the top was Hurricane Ian, but Kentucky got a severe flood in July, killed 28 people. And then 10 severe weather events, tornadoes, derechos, that sort of event happening mostly in the plains in the Midwestern area. And you can see the deaths, which I've put down there, and the numbers that are in white or in that pink color. The number of deaths in India and Pakistan were much greater than the deaths that the US experienced for our weather events. And it was mostly due to the flooding that happened in those areas because of that wet weather that was pushed westward across the Pacific and into the Asian continents. These are the weather disasters. Betsy already reviewed some of them. I do want to mention that the drought in the Mississippi River Valley has been huge in terms of its impact. There are places where you can practically walk across the Mississippi, and it's really had a major impact on transportation. Remember, I mentioned it transported a lot, like 75% of our grains, something like that, at some point are in the Mississippi River system. And then the drought in Colorado. They are very close to reaching a condition where they won't be able to generate the electricity needed. So we've got some real problems. And then there's California and what they experienced in 2023 with their floods and the huge snowstorms from the atmospheric river event. Groundwater in the Southwest is in crisis. It's being overdrawn because the surface water itself has been over allocated, and we've got this incredible population increase. The population increase over the last 70 years has been about over 200% in the states that are in red, and you see it corresponds with the states that have the most difficulty with their groundwater reserves, and growth is continuing and is going to continue to generate more demand. So what can we do?
Barb,
yeah.
I'm the timekeeper right now, and your 15 minutes has expired. Are you close to the end?
Pretty close. Let me just say that there are things that government can do. And you can read and you may as well read. I don't need to say it, but there are the big step things like developing guidelines for landscaping and development. Industry, our 2 big ones are irrigation and cooling thermoelectric power plants. Those 2, we really could stand to bring in some new technologies. Data centers also could start recycling and reusing water. They use a lot to cool their machines. For you who are consumers, if you go out and buy 1 t-shirt and 1 pair of jeans, the amount of water it takes to create them, you would provide your drinking water for 13 years. So use your clothes up. Don't just buy for new seasons. For individuals, check your leaks, run your washers when they're full, take short showers. There are a lot of techniques that I'm sure most of you are familiar with, and eat, as Betsy said, low down on the food chain. The amount of water taken to create different foods, you can see increases dramatically as you move to the meat products. And that's a little humor. We don't need to watch that. And that's the summary of HOPE. We will be sending this out with a couple of additional resources when you get the PowerPoint, the presentation link. We'll be sending that a PDF of those resources. So that's it.
Okay. Well, this is a lot to absorb, isn't it? I think when you hear it all together, it's phenomenal. So I want to offer thanks to the three presenters who did an incredible amount of work. So yay to all you guys. And then any general questions or inferences that you kind of want to just acknowledge or whatever, any things that you found yourself processing in your head as you were doing this, just as comments.
I think we've overwhelmed everyone.
I think so. It's a lot of numbers is part of the problem. And one thing I wonder is maybe Betsy and Angie and I could do it is to figure out which of our slides convey information that people might find useful. And we could put that together into a PDF that we could send out also.
You know, I found myself thinking about, I'm in a senior independent living place, and I found myself sort of thinking, you know, if I got together with it's a fairly progressive group, and if we all agreed that at least one night a week we were going to ask the kitchen to just do a completely plant-based diet, and see if, and then what would be fun is if you can send me those figures on the gigatons of whatever, and we could, you know, in terms of selling it to everybody, we could then say that. So what I'm saying with that is not just what I can do, but let your own minds think about the way you live and the styles that you have, and in what ways might each one of us individually, without making a significant change, because something has to be sustainable. You know, it's sort of like with a diet. You know, if you go too hardcore, you're not going to stay on it. But if you do it in a way that you can do it and sustain it over time, that's what we're looking for. So that was what I was aware of. What about any of the rest of you? We've got a little.
Yeah, Kathy, I'm in a senior community as well, and we do have a global warming action group, and they're constantly looking for things like that. And I think that they are leaning on the kitchen to have more, if not taking the meat off the menu, because there are a lot of people who would object to that, but offering many more vegetarian possibilities so we can individually choose that.
Mm-hmm.
It's a good way to do it. Yeah.
The other thing you can do is we're still living in the house we've been in since 1979. But in a group setting like that, you can suggest that they move, even if they're staying with meat, maybe they move away from beef, because I mean, more than anything, beef is a huge culprit. But you know, you can still eat chicken, you can still eat some pork, you can still eat lots of fish and seafood, and so you don't have to go vegan. And you can still make a difference.
I will say that I have found that the plant substitute for beef, the Beyond Beef or whatever, makes better meatloaf than beef.
Yep.
Oh,
Very good.
Oh, I want to put in a plug for the regenerative agriculture community. You know, I know when we were the group of us who organized this talk, Kathy was saying, well, that sounds great, but how am I going to figure out what food to buy? So I actually went on the internet and I Googled, you know, regenerative, where's a regenerative farmer near me or something like that. And there are websites, there's regenerativefarmers.com, and it lists all these farmers who are sort of, you know, are regenerative farming. So it's a thing out there. You know, it's something that we can actually, you know, look for in our community and support those companies. Mm-hmm. And the other thing is the deal with, I have this thing about lentils. They are really, really, they're so good for you. There's as much protein in a half a cup of cooked lentils as there is in 1 ounce of a steak. So lentils are packed full of protein, and vitamins and fiber.
Fiber, yeah.
Yeah, and if you go on the Timeless Seeds website, they they have all these recipes for them. They have all these different colors of lentils, and they just, I don't know. I just have a thing about lentils, lentil salad. So that's I have not, and I do know the Timeless Seeds farmers, but I'm not trying to get them more money or something.
Okay, Rachel has got a raised hand and so does Kier. So Rachel, you first and then Kier.
Hi. I just wanted to pipe in with kind of steps I've been taking the past couple of years. Doing the composting has been very easy and way easier than I thought. And so if you're able to compost, please do it. It actually helps us on our garbage bill. We're doing, we only have in a 2-person household with a cat and a dog, about 1 bag of garbage a week. And I also started this year, I started doing a frozen baggie of scraps. A baggie of scraps whenever I'm prepping in the kitchen. And then by the end of the month, I make veggie stock and do something with it. And then I also have a fun recommendation. If you don't have space, a lot of space in your home, the Arrow Garden is really fun. They come in different sizes. I have a 6-pod one, and it's a little water, what's the word for hydro
Agriculture.
Hydroponic.
yes. So it has little pods that you can do like Italian herbs, or you can do lettuce. I have lettuce in there right now, and it's just like a fun little way to do a little bit of gardening at home. And I buy a little bit less greens at the store, but those are a couple of things we do. And also, and if you don't have the space, you might have a neighbor or something, or that your city might do free composting. So I know I've lived in a couple different places in the last few years, but now we have a whole double lot at our house. So we have lots of garden space, and we have lots of space for our compost, and it's so good. And now it's like working for us. It's taken a couple of years, but yeah.
Maybe we can put those pods and something like that in that PDF list. And I'm aware of time, but Kier, you had your hand up, so why don't you ask your question? Then we also we are at the hour mark, and we need to see if people want to stay on, those that can. But I'm one of these people that if you've said it's going to be an hour, you should at least not make people feel guilty if that's. So Kier,
I don't know. What else have we all got to do? My question, I mean, it's great to think of all the things that we can do individually, but and I know you've been recording this. Are you recording it just to share so that other classmates can see it, or are you going to share it with other people? And I guess I'm going a little farther than that. My land conservancy has been doing this wonderful biodiversity series. And I know that Rachel, who heads this up, Renee, would be really interested in possibly getting together with the three of you, and maybe, having you make a presentation we get over 1,000 people from all around the world and the country who participate in these sessions. So can we expand, and would you guys be willing to, now that you've gathered all this information, to go on the road?
Go on the Zoom road.
Okay, I'm going to turn that one over to Marty to follow up on and see, organize whether we want to do that, and that will that's a great idea, because I think it is a matter of how do you scale it up once you get to individuals. How do you scale it? And that's what I was thinking of within my community, but that's an even greater scale.
I mean, they did such a great job of condensing it into a biteable. I mean, yeah, there's a lot of figures, but still the the visuals and that were really succinct, and they were terrific.
And just an hour presentation.
Yeah.
Yeah, and that's great.
57 minutes.
Who's counting?
I just want to say, Kira, I really appreciate that, because we put way more time into this than we ever thought we would. But I wanted to do it because I wanted to feel like I was doing something about climate change. And I do think one of the things we can do, and this is what I like about that book that Betsy pointed out, Drawdown, is, we have the resources, we have the wisdom, we have the time to really try to do something. And so if we can go talk to people and spread the word, that's great. And just, like in your book club, choose a book about climate change, because we all need to be talking about this.
Yeah.
So,
And
My book
Betsy
club would
points out-
like to do it too. I mean, I can see them wanting to do this. So
And Betsy keeps saying, vote climate too, vote climate.
Well,
Yeah.
Nancy's been trying to get in.
Yes.
First.
Am I muted?
Nope.
No. I just wanted to comment, I live here in New Mexico, which is right in the heart of a terrible, horrible drought. And Barb, I'm so glad you pointed out that we're also going to run out of electricity because of the Colorado River. And it just makes me sort of snicker when everyone is saying in the Southwest also, we all need to get electric cars, electric cars, electric cars. Well, I don't know any of the numbers for how much electricity a car would draw to keep it charged, but cities are going to run out of electricity. So when you have new development out here in the desert, not only do the developers sort of have to pull the wool over everyone's eyes that there's enough water to feed all these homes, but now they need to pull the wool over everyone's eyes that there's enough electricity for new homes and for growth. I mean, it is an amazing crisis that sort of is being hidden or is not being talked about or is not as urgent as I might like it to be for both water and electricity.
And one of the things, especially out there in the Southwest, is there are places where the crops that are being grown have no business being grown in the
Absolutely
climate,
true.
in the climate that exists there.
Cotton.
Right, that is just
Oh,
so
well,
true.
Yeah.
Food
Including,
items, almonds. We
Yeah.
should, almonds
Almonds.
use an incredible amount of water.
well, one of the ways I see that of growing plants that shouldn't be here is just in gardens, of friends, and sort of I may be a little guilty too, and the garden centers that sell trees that are going to need to be watered all the time, perennials. I can go to 2 garden centers here and see all the perennials that I used to be able to buy in Massachusetts. Now, that doesn't fly, that doesn't work. Because even if you water these perennials more than you should and consume more than your share of water, the perennials have a heat limit. They can, just like they have a cold limit. You can't get them, but you have to be in the right zone. We have to be in the right zone for heat also. And many of these New England perennials that I see in these places will not survive a series of 100-degree days, period, the end. They won't make it through. So we're all being, or pretty stupid about water, plants, and electricity.
I'm
Yeah.
wondering, because I'm sometimes way too obsessed with time. What I'm wondering is if it would be any appetite for an informal forum where each one of us that feels so inclined could be thinking about, because we could all of us spend time, and I don't have any interest in doing that, just talking about all of the ways that this is really bad. I want to move to how we can make it better. And I think our generation has always raised a lot of stink around a lot of things that have happened all the way through. So we might as well go out with that too, you know. So,
it's really interesting, Kathy, that I just read an article, I can't remember if it was in the New York Times or the Washington Post, about how people of our generation, you know, we think of the young people as the ones who are really fighting hard to mobilize governments to act in the climate crisis. But there's this growing wave of those of us who have gray hair who are coming out and joining this fight. And I think that's great. I myself feel guilty about the damage, you know, we have sort of mindlessly caused to the Earth's ecosystem. So I think it's high time we all stepped up. There are just two things I really want to say, and one ties back to what Keir raised. There's a Center for Communication about Climate Change at Yale, and they consistently say the most important thing any of us individually can do, along with these particular lifestyle things, is to talk about climate change. I think probably most of the people we know are pretty aware of it. Although I can tell you, I have relatives who are way over on the right side of the political spectrum. And it's really important to talk with them, not in a threatening way, not in a demeaning way, but just to communicate what we know and understand about climate. And then, yes, the other thing is vote climate. I mean, there are many, many really serious issues in the world, any one of which could consume our interest, but climate, it's just, if we turn the world to toast, none of those other issues is going to
Doesn't make any difference.
survive. Yeah.
It's an existential problem.
yes. And
I think Bill McKibben's new book is just on that, that our generation has the time and the
Yeah,
smart
it was McKibben.
and the commitment to do it. And he's done so much to try to educate people about the climate.
well, I think it's 5:15 now, and would there be any appetite to just sort of see as to whether or not we wanted to do some action-oriented stuff? I mean, I'm thinking just within this call, we have people all over the United States, so that we become a true grassroots in a lot of different places. So I don't know. I'm open.
Can I suggest that when we send out the resource list, part of the message that goes with that is just a query about
It's good.
That's a good way to do it.
might be
Yes.
interested in an ongoing conversation.
Yeah.
You
and-
guys, do you want to stop recording now for
Yes.
this portion? Okay.